Let's use the Lorentz transformation to find the time dilation formula delta t equals gamma delta t naught for clock moving in frame s prime at speed u. So this clock is at rest in s prime, it's at the origin o prime, and measured in s prime, it has a rest time, delta t naught, that's the time it takes to tick when it is stationary, so the speed is 0, whereas in frame S, it ticks with a time delta t, and time dilation gives that delta t is equal to gamma times delta t naught. So what we want to do is find the time interval delta t, which is the time between two events, event 1 and event 2. In S prime, the events occur at times t2 prime and t1 prime, and the time interval delta t prime is equal to t2 prime minus t1 prime. And this is the rest time delta t naught, because the clock is at rest in S prime. Incidentally, this delta t naught is also called the proper time, and the proper time is time measured at a point fixed in space in a frame. So it would be for an object at rest, such as a clock that's ticking, and you're measuring the time shown on the clock. For this clock, the position x1 prime is equal to 0, and at the later time x2 prime is also equal to 0 because the clock is at the origin. This analysis could work for the clock in any position. So for example, if the clock were over here instead of at the origin, then it would have some position xc, let's say, for the clock, in which case we'd have x1 prime is equal to xc and x2 prime equals xc. Well, let's give those xc a prime so that it's in the prime frame, and that clock would be at rest, although not at the origin. We want to find delta t and relate it to delta t naught, so we'll use the inverse Lorentz transform to find delta t. So first of all, t2 is equal to gamma t2 prime. For the inverse, it's plus u x2 prime over c squared. And the time t1, the earlier time, is gamma t1 prime plus u x1 prime over c squared. And delta t is the difference between these two. So delta t is t2 minus t1. And we can see from here there's a common factor gamma. And then we have a t2 prime minus t1 prime, which I'll group. And then we have u over c squared times x2 prime minus x1 prime. Now, because x2 prime and x1 prime are both 0, this is 0. It would also be 0 if the clock were not at the origin, but at this other position at which it's stationary, so that the x1 prime and x2 prime are equal, in which case they would subtract to give 0. Therefore, delta t is equal to gamma times t2 prime minus t1 prime, which is delta t prime. This term here is 0. So since we have delta t equals gamma delta t prime, and delta t prime is equal to delta t naught, we have delta t is equal to gamma delta t naught, which is the time dilation formula.